Hello everyone, myself Rahul. In this presentation, I'll be explaining about conversion of Epsilon NFA to DFA in automata theory and compiler design. Conversion from Epsilon NFA to DFA. Automata are abstract models in computer science studying symbol manipulation process. Key types include finite automata and Turing machines, influencing language and theory computation. DFA, a computational model, has finite sets, input alphabet, unique transitions, and acceptance based on the final state. Simple, predictable, applied in language recognition and compiler construction. NFA is a computational model, has states, input alphabet similar to DFA, and it also has transitions, initial and acceptance states. This allows multiple transitions, non-deterministic behavior, and hence it is called NFA, applied in pattern matching and language recognition. So I'll be explaining about conversion of this epsilon NFA to the DFA and how to do this step by step. In the conversion from an epsilon NFA to a DFA, we organize states into groups in the DFA, where each group signifies all potential states we might find ourselves in at a specific moment. This simplifies state transitions, providing a clear and deterministic path on the received input. So basically, we are combining two or more input these states and giving it in a group. So first let us consider the epsilon NFA table, state table and epsilon closure for the given epsilon NFA. So in this state table we have included these three states Q, R and S. So the Q state on giving input A, it takes to the position Q itself. There is a self loop in it, and Q state on giving input B it doesn't take it anywhere. So we have specified null operation. On even for C, it doesn't take to any position, any state, so it is null. Then for epsilon, it moves from Q state to R. So we have mentioned R. Similarly, we have done for the state R. it it doesn't have any movement from the current state to the new state while giving the input A, so it is null. When we give input B, it goes to the same state, that is R, and on giving C, it doesn't go to any other state, so it is null. So on giving epsilon, it takes to other state S, and let us check for S. S on giving input A doesn't go anywhere, so it is null. Similarly for B, it is null. And for S, it comes back to this, for C input, it comes back to the same state, and we have mentioned S. And for epsilon, it doesn't go anywhere and stays in the same place, so it is null. Here we have mentioned start state with the arrow mark behind the Q and final state with this asterisk behind the S. So how to find epsilon closure? So epsilon closure means that from one state to the till the final state, which moves can we form by the epsilon input. Here we can see on giving epsilon input to the Q, we can go to R. Also giving same epsilon input, we can go to S. So we must include Q, the same state. Then we have included R and S. So here we can see for R, epsilon closure for R, we can only include S for it. Since on giving epsilon input, we can go to S. If there was any other arrow mark for Q, then we could have included Q also. That is QRS. So there is only one arrow mark, so we have included RS. And for S, on giving epsilon input, it doesn't go anywhere, only we can include the same state. Now we have to generate transition table to draw the DFA. So to generate this transition table, we have to include this starting state. So we have considered starting state as the epsilon closure of Q, that is Q, R, and S. These three were the states which was given for epsilon closure of Q. So it is the starting state, and we have indicated with the arrow mark. Now, when to get these states, we have to give input A, B, and C. So we'll check with all three inputs A, B, and C. On giving input A for the QRS, this state, we'll get epsilon closure of NFA, QRS, and input value A. It is nothing but it is union of all these three inputs, like for giving for Q, giving for R, and giving for S. We'll get for the first one, we'll get when we give the input A for Q state, we'll get Q. Then when we give input A for the R state, we'll get 5 from here, that is null. And when we give A for the S state, we get null. So we have mentioned this Q, null, and null. On performing union operation on all these three, we get only the Q state. So epsilon closure of Q, we already know that it is QRS. So we'll mention it here in the A column. Similarly, we follow it for B also. When we give the input B, the QL state takes the input B and it doesn't go to any state, so we have mentioned it as null. And when we give the B input to the Q state, R, it takes us to the R state. Then when we give C input to the R state, we get null. So we have mentioned epsilon closure of R on performing all these three union operation, we get RS. Similarly, we follow it for C and we get S state. There is only one state possible because on giving all the inputs, it doesn't go to any other state and only it takes to the S on giving C input. So similarly, we have to do it for the R and S state. We have included RS as the second state because this is the new state which we have formed, which we have found, that is QRS, QRS were already present. So RS is the new state which we have found. So it should be the next state which we include. On giving the inputs, we get these specific values, and also for S, we get these specific values. So this helps in drawing the DFA. So we have got these three states and now we have to draw the DFA. Here we can see there are three states included from the table. All these three are indicated with two circles because all these three are final states. So on giving input A to the QRS state, there is a self loop that it exists, it comes back to the same state. And on giving B input to the QRS state, it takes to the next state, that is RS. And on giving C input to the QRS state, it takes to the final position, that is S. Even it is also its final state. Similarly for RS, it doesn't take anywhere to the input A, so we have not indicated here. On giving B input, it takes to the same state, and on giving C input, it will take to the next state S. Similarly for S, on giving C input, it takes to the same state, and on giving A and B, it doesn't change the state, it remains in the same state. You have understood conversion from epsilon NFA to DFA. Thanks for watching. Please like the video.